In this lesson, we're going to look at how you execute shell scripts from the shell prompt. Now, this is very important because if you don't configure your shell scripts to be executable, then they won't run. For example, if I had a script file that I created and I named it showdate and I saved it in my home directory and then tried to run it from the shell prompt, absolutely nothing would happen except for an error message on the screen. This happens because by default, the bash shell sees this file as a text file. And you know what? You can't run a text file. There are two options for getting around this. The first one is to actually call the shell executable itself, which is /bin/bash, and then tell it to execute the script file. So in this example, at the shell prompt, I would enter /bin/bash and then tell it to run the showdate script located in my user's home directory. Now this works, but it really isn't the best option. If you're going to be running your scripts, yeah, this will probably work okay. But if you expect some other user to be able to run your scripts, then more than likely they're not going to know they need to call the shell executable itself and run the script within it. A better option is to go ahead and assign the execute permission to the text file. With the execute permission assigned, any file, including a simple text file, can be allowed to execute from the shell prompt. And this is a great option for making scripts easy for end users to run. To do this, you simply enable the execute permission for owner or for group or for others or any combination thereof. And this is done using the chmod command. So in the example we're working with here, I can allow the showdate file to be executed by the bash shell by adding the execute permission to whatever users we want to be able to run it. For example, let's suppose that I only care about allowing myself, the file owner, the script file owner, to execute it. To do this, all I have to do is add the execute permission to the owning user. And I could use this command to accomplish this. I enter chmod u, which stands for user or the file owner, plus x. That tells chmod to add the execute permission to the owner. An example of that is shown down here. I've entered chmod u plus x showdate. And notice down here in the output of the ls-l command that the file owner now has the execute permission. You could accomplish the same thing using numeric permissions as well. Just use chmod 744 showdate, and that will also add the execute permission to the file owner. Remember, when we calculate permissions numerically, read has a value of 4, write has a value of 2, and execute has a value of 1. So if I want my user, the file owner, to have read, write, and execute permissions, I just add these together. 4 plus 2 plus 1, which equals 7. Because group and others have 4, they're allowed to look at the file, they have read access, but they're not allowed to write to it, nor are they allowed to execute it. Now, with the execute permission added to owner, I can then run this script from the shell prompt. All I have to do is enter its name just as I would any other system command. Now, of course, you could also allow group or others to execute the file as well. Just do a careful evaluation of who you want to allow to execute the script and assign the appropriate permissions. There is one other issue that you have to be aware of when you're working with scripts, and that is the issue of paths. Now, notice in this example that in order to run the showdate command, which resides in my home directory, I had to enter basically the full path to that command. I entered a ./, which indicates the current directory, and then the name of the file. Even though the current directory is my home directory, I have changed to the directory where the showdate command resides. Even though that is the case, if I do not provide the full path to the showdate file, as in this example, even though I'm in the same directory where showdate exists, if I try to run it from the shell prompt, I get a command not found error. Here's the problem. My home directory, which in this case is /home/rtracy, this directory is not in my path environment variable. If I had not explicitly indicated the path to the script file in the first example here, then I see the error. If I do supply the full path to the file, then the bash shell knows where it's at, and it doesn't have to look through the path environment variable trying to find it. Here's the key thing to remember. If the script resides in a directory that is not found in the path environment variable, you must specify the full path to that script file in the shell command. Otherwise, the bash shell has no idea where that file actually exists. If you're creating scripts for yourself, scripts that you will just run, this probably doesn't pose a problem. But if you're creating a script that you want your end users to be able to run, then this is a problem. And I can guarantee you that you'll get complaints because they won't remember to include the full path to the script file. So to save yourself frustration, I recommend that you consider putting the script file in a directory that is part of your path environment variable. For example, one option would be to place the script in the bin subdirectory within each user's home directory. Now, most Linux distributions automatically create a directory named bin by default within each user's home directory. And then one of the bash configuration files automatically adds that directory to the path environment variable when the shell is originally started. So you can see that /home/rtracy/bin is in the path. And because it's in the path, any files I dump into this directory can be run from the shell prompt without specifying the full path to the file. Alternatively, you could do just the opposite. You could take the directory where that script file resides and add it to the existing path environment variable. To do this, you need to use two different commands. First, we use path equals to set the value of the path environment variable. And notice here that we first grab whatever the current value of the path environment variable is. Otherwise, we will overwrite the path environment variable and nothing will work properly on the system after doing so. So we first of all reference the existing path environment variable with $path, and then we append to the end a colon followed by the new directory path that we want to add, and then we export that path. When you do this, it is absolutely critical that you don't forget to include the existing path assignment in the new value of the path environment variable. If you don't do this, then the current directories in your path environment variable will be erased and will be replaced by whatever path you specify in the command. And when this happens, your system's going to start to experience a host of problems and you're not going to be happy. Now, at this point, we've added the path to our environment variable, but we still have one other thing we need to do. We've assigned the value of path to include the additional directory, but that new value of path will only apply to the current shell session. That means if I were to open up another terminal session, I would see that the change that I made to the path environment variable right here would not be applied. In order to make this assignment apply to all shell sessions, I need to export the new path environment variable. To do this, you just enter export path at the shell prompt. And after I do this, then the new value that I assigned to the path environment variable will be made available to all other shell sessions, including any subshells that are created by the current shell. Now, one problem you're going to encounter in this process is the fact that any new value you add to the path environment variable will be lost after the system reboots. And more than likely, you're not going to want that to happen. More than likely, you're going to want this change to be persistent across system restarts. In order to do this, we need to edit one of our bash configuration files and add these two variable assignment commands to that file to make sure that every time the system starts, that change is applied. Now, at this point, you have to decide which shell configuration file is the right one to use. And it depends upon two things. Number one, it depends upon your distribution, because some distributions use one set of files, other distributions use a completely different set of shell configuration files. So you have to look at your distribution and figure out which one it uses. And then you have to decide the scope of this change. Do you want it to apply to just one user on the system, maybe your user account? Or do you want this change to be applied to all users on the system? If you want this change to apply to all users, then you need to make the change to a global bash configuration file, such as the /etc/profile file. This will cause this change to be applied to all users, regardless of who it is that logs in. If, on the other hand, you only care about making this change for a single user, such as yourself, then you just find the appropriate configuration file, hidden configuration file within your user's home directory, such as .bashrc, and make that change there. And then it will only be applied to your particular user account. Everyone else will not receive the change. That's it for this lesson. In this lesson, we talked about how to execute a shell script, and we also talked about how to deal with path issues when executing a shell script.